Welcome to this video on adding and subtracting fractions or signed numbers. So if you've not already watched my videos on adding fractions, you really need to do that. Because the only difference here really is that we're adding in some subtraction or negative signs. And the rules for those follow exactly the rules for adding and subtracting signed numbers. So we're really just combining the rules for adding fractions and the rules for adding and subtracting signed numbers, and we're putting them together in a single problem. So let's get started. So suppose I have 2/3 minus 1/2. So 2/3 I could visually represent in this picture here by shading in 2 out of the 3 slices, and then 1/2 I could visually represent that by shading in 1 of the 2 slices here. So remember, in a fraction, the denominator tells you how many equal size slices your whole is divided into. In this case, it's 3. And then remember, the numerator tells you how many of those are being chosen. So in this case, that would be 2. Okay, likewise, we have a circle that's divided into 2 equal slices. So the denominator is 2, and we're choosing one of those. So we have 1 out of 2. So remember, it doesn't make sense to add or subtract across. So in other words, if I did 2 minus 1 equals 1, and 3 minus 2 equals 1, right, this has no meaning at all. It doesn't make sense to just add or subtract across. Okay, so remember, just like we said in the other videos, what we have to do is we have to make these pies look identical. In other words, we have to cut them into the same sized pieces. So we can, if you think about the numbers 3 and 2, 3 times 2 is 6, right? So the 6 in this case is going to be our least common multiple or our least common denominator. So that means that I have to take each of these 3 pieces and cut it in half, like so. And then over here, I would have to take each of these halves, and I would have to cut it into each of those into 3 equal slices. So now if you stare at them, they might look a little bit different because of, I did it by hand, but they both have, right, 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6, right? They both have 6 equal size slices. So now they look the same, right? And the slices, the sizes of the slices are the same. So now it actually makes sense to add the number of slices, right? So we have 2 times 2 is 4, and we have 3 times 1 is 3. Okay? So literally, if I'm doing 4, 6 minus 3, 6, right, that says, okay, you start out with 1, 2, 3, 4 slices, right, and you take away 1, 2, 3 of them. How many are left? Well, 4 minus 3 is 1. So the answer here is 1/6. So in other words, 2/3 minus 1/2 is equal to 1/6. Okay? So again, hopefully you can see that the rules of fractions and adding fractions are exactly the same. Literally the only difference between these problems I'm doing in this video and the problems I did in the previous video is that we're subtracting instead of adding our numerator. That's all. That's the only difference. So let's keep going. So here we have 1/5, so that means that one of these slices is shaded, and then minus 1/3. So one of these slices is shaded. So let's make a prediction about whether our answer is going to be positive or negative. If I look at the size, which of these pie slices is bigger and which one is smaller? Well, it looks to me like this one is smaller and this one is larger. So if I have a smaller number and I'm subtracting off a larger number, I'm probably going to end up with a negative number. Okay, so I'm predicting that my final answer will be negative, and visually that makes sense, right? Basically, I'm taking away more than I started with. So let's look at our two numbers 5 and 3. So 5 and 3 are both prime, so the easiest way to find your least common multiple in that case is just to multiply them. Okay, so visually what that means is I'm going to take each of these 5 slices and I'm going to cut them into 3 equal sections. Okay, and then that means on the other pie, I'm going to take each of these really quickly. Sorry, that's the same as multiplying by 3 over 3. Right, and then on the pie where there's 3 equal slices, and this is a little bit harder to do freehand, so forgive me here. Okay, I'm going to cut each of these thirds, okay, into 1, 2, 3, 4, 5 slices. 1, 2, 3, 4. Okay? So, again, I multiplied 1/5 by 3 over 3. I multiplied 1/3 by 5 over 5. So now I have, right, multiply across 3/15 minus 5/15. So let's write that at the top. We have 3/15 minus 5/15. Okay? So that's literally just 3 minus 5 all over 15. Well, you can put that in your calculator. What's 3 minus 5? 3 minus 5 is negative 2. So the final answer is negative 2 over 15. Okay, and again, that makes sense, right? I started with 1, 2, 3 pieces. I took away 5, right? So if I take away more than I had, then somehow I'm in debt, right? I have negative 2 pieces because, again, 3 minus 5 is negative 2. Okay, so hopefully you can see that the process of working with fractions, whether you're adding or subtracting, is exactly precisely the same. Again, the only thing that changes here is that in the numerator we happen to be subtracting rather than adding. Okay, let's do another example. Okay, so this problem I have negative 1/4. Ooh, that's interesting. Okay, so this time we're going to throw in some negative signs in there. That's okay. So negative 1/4 minus negative 5/6. Okay. Oh, sorry, minus 5/6. I apologize. That's not negative. Okay. So, once again, we have this problem where we have one circle divided into 4 equal slices, the other one divided into 6. Okay. So remember, you have 2 options, right? You can think about 4 and 6, right? If you think about 4, that's 2 times 2. And if you think about 6, that's 2 times 3. So if you want to build your least common multiple, well, they both have 2. And then this one has a 3. I'm sorry, this one has a 2. And this one has a 3. So you could say, okay, well, my least common multiple is 12. Right? So what is that going to look like? Well, that means that each of these quarters are going to get divided into 4 equal slices. I'm sorry, each of these quarters is going to get divided into 3 equal slices. I apologize. So that would give me negative 3 over 12. Okay, and then, right, each of these 6 slices, right, 6 times 2 is 12, right? So then I'm just cutting each of these 6 slices in half again. Did I do that right? I think I did. Okay, so that would get me 10 over 12. Okay, so again, you don't have to do this, right? This is only one way to do this. I'll show you the other way in 1 second. So right now, according to this picture, I have negative 3 over 12 minus 10 over 12. Okay, so if you want to, you can rewrite it as just, an integer problem all over 12 because you know the denominator is not going to change. So I start out with negative 3 slices, right? So I have 1, 2, 3 pieces, but again, they're negative. So you could think of it as borrowing 3. And then I take away 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 more. Okay, so negative 3 minus 10 is negative 13. And again, that's all over 12. So let's say that trying to find the least common multiple or least common factor is very frustrating to you, okay, which it is to a lot of people. So you're not alone. Don't feel bad about that. Okay, so we have negative 1/4 minus 5 over 6. Okay, instead of spending a lot of time trying to figure out that 12 is the smallest number that is evenly divisible by both 4 and 6, what we could do, okay, quick and dirty method here, we could multiply one fraction by 4 over 4, the 4 coming from here, and then we can multiply the other fraction by 6, the 6 coming from here. So let's work this out and see if we get the same answer. So 6 times negative 1 is negative 6. 6 times 4 is 24. 5 times 4 is 20. 6 times 4 is 24. So we have negative 6 minus 20. You can type that into your calculator. It gives you negative 26 over 24. So all that's left to do now is to reduce it. Both of these are even numbers, so I can divide them by 2. And I end up with exactly what I did before, which is negative 13 over 12. Okay, so please understand, please know you don't have to spend a lot of time finding the smallest number that is divisible by 4 and 6, because the product of 4 and 6 is always going to be divisible by 4 and 6. So that's something that always works, and it's a much simpler process than trying to find that smallest number. Okay. So let's do one more problem. So here we have negative 1/6 minus negative 3/8. So in this problem, what I'd like to do, with your permission, is I would like to just go straight for that quick and dirty method that I just showed you. So really quickly, let's just represent this visually. So we have 1/6, so one pi piece shaded here, 3/8 over there. Okay? So again, rather than figuring out what the LCD is, or the LCM, right, I'm just going to multiply 8 times 6 and 6 times 8. Okay, I'm not going to waste my time with that other stuff. So 8 times negative 1 is negative 8. 8 times 6 is 48. Negative 3 times 6 is negative 18. 8 times 6 is 48. Okay, at this point, okay, you can rewrite this as just a integer problem all over 48. So in your calculator or in your head, you can do negative 8 minus negative 18. Okay, remember, minus a negative becomes plus a positive. Negative 8 plus 18, well, that gives me 10. So we have 10 over 48. And last but not least, what we have to do is we have to reduce it. You always have to reduce. So that becomes 5 over 24. So it turns out that 24 was our LCD. So you might have thought of that. You might have realized that, right? And if you had done that, you would be like, oh, well, I would multiply this by 4, and I would multiply this by 3. So that is another acceptable way to do this. Okay, so find the way that is most comfortable for you, that works for you, and stick with that method. Okay, let's do one more problem. I know I said this was the last problem. I think we have one more in here. So let's suppose we have negative 1/2 plus negative 3/5. Okay, so in this case, the 2 is missing a 5. The 5 is missing a 2. So this is going to give me negative 5/10 plus negative 6/10. So literally I have negative 5 plus negative 6 all over 10. If you type that into your calculator, that's going to give you negative 11 over 10, right? Because negative 5 plus negative 6 is negative 11.